Now let's finally try to find a way to write an equation. Here we're talking about commuting, and we have this commuter train that has a non-stop service, which is kind of weird when you try to get on and get off of the train, but there's very few people that have injured themselves. A couple bruised knees, no big deal. But it is nice and quick. So what it does, it goes from one city to another, a distance of about 25 miles. So what we need to do is we need to write an equation to represent the travel time between these two cities as a function of rail speed, then graph the equation. So what we're going to do is we're going to first let the equation of d equals rt, distance equals your rate times your time, be what we're going to use. So we know that our distance is 25, and we don't know what our rate is, and we don't know what the time is. We have two variables here. So we want to write an equation to represent the travel time. So if we're trying to represent our travel time, we need to solve this equation for t. So to solve that equation for t, we just divide both sides by r, and we would say t is equal to a 25 over r. That would be your equation that we have. So then your time is going to be whatever your distance is divided by your rate. So if we want to graph this, then we're going to make a table of values where we have your r is basically where your x is, and your t is wherever your y would be. So when you do this, if we set your denominator equal to 0, r equals 0, that's going to give us your undefined value. You can't put a 0 rate and get somewhere in any amount of time. So that's going to be your undefined value. So what we can do to find your rate is we can surround this with multiple values. Well, you can plug in, we'll just go by 5s because that'll make it a little bit easier. How about -5, -10, -15? And then on the right side we'll go +5, +10, +15. So let's think about this for a moment. If we are talking about a rate, so how fast something is traveling, if we have negative values, how much sense does that make to put in a negative rate into our table? Probably about none, because you're not going to have, then you're going to end up with a negative time. Well, you can't have a negative rate and a negative time in the context of this problem. So let's just get rid of these here. So what we're going to do is we're going to extend our table a little bit and maybe make our rates a little bit larger. So we're going to go 20 and 25. So now by plugging these values into your equation, if you have 25 divided by 5, that is going to end up and give you 5. And this would be your travel time is in, oh, what's it say? Doesn't even say. If you plug a 10 in there, you get 25 divided by 10. Well, that's just a 2.5. If you have 25 divided by 15, that is a 5/3 or a 1.67. Plug a 20 in there, that's a 5/4, which is a 1.25. And if you plug a 25 in there, that's just going to give you a 1. So if we graph this function, we're only going to need our positive values of r. So here is where we're going to put our positive, or this is going to be our, this will be your r-axis, and this will be your t-axis. So your time, let's go by, we can go by 5s here. So go 1, 2, 3, 4, 5, and there's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then we go 1, 2, 3, 4, 5, there's 25. So those are your R values. And then as we go up, well, you can go by bigger numbers because your T values are a lot smaller. So let's go by, I can still go by 1s or maybe halves. So half, say here's a 1, 1/2, 2, 2.5, 3, 3.5, 4, 4.5, 5. So let's plot our points. So we're going to say 0, well, you can't have anything here. You can go over 5, up 5, so you have a point right here. We have over 10, up 2.5, so a little bit slower. over 15 up 1.67, so that would be right around in here. Over 20 up 1.25, so that'd be right about here. And then over 25 up 1. Notice your graph never touches 0 either direction. And so as it goes to the left, it goes up like so. So if R is your rate and T is your time, what you can do with your reading this graph then is the slower the rate, the higher your time is going to be. But as you increase your rate as you're going to the right, the slower or the less time you have. That should make sense. So anytime you have any limitations for your domain range, well, in this case, you would just say your rate and the time both are greater than 0. They can't be 0 or negative. So that is how you can actually use a reciprocal function to help you figure out a real-life problem.